about 1,500 feet above sea level. You can see a large valley way below. We experience 2 rainy seasons per year, May through June and September through October. During these times, we utilize a canal system, which is not visible, to catch some of the rapid rain runoff from these steep mountains and hold it in the tailings dam. When needed, the water is pumped back up to the mill for production usage. Okay, the reason I stopped is that there are many homes scattered down the valley and around the area, indicating that there is a large available labor force close at hand. The grinding mill and flotation circuits are housed in the metal buildings below, along with necessary workshops, storage areas, warehouse, and garage. The last building you see is our power generating plant.
This is going to be a brief explanation of the location of the mine, the geology of Haiti, and the geology in the mine area. The Haiti mine is located approximately here, which is about 100 miles from Port-au-Prince here, and 12 miles from Guanani. In general, the rocks in Haiti are limestones of Eocene age, volcanics of various ages, Eocene to Cretaceous, and intrusive rocks which were formed deep under the Earth's surface. Now to go on. This is the general plan, a composite plan of the various adits and tunnels in the mine. The blue, as you see, is the main adit level, 1,500 level, which is actually 1,500 feet above sea level. Number 9 adit is here. It is also at the same elevation as 1,500 level. We have an upper adit, number 2 adit, which is at 1,300 foot elevation in yellow. The lower levels, the orange is 200 feet below the 1,500 foot level. This is a 1,700 foot level. And the green is a 1,900 foot level, which is 200 feet below the 1,700 foot level. This map shows the arrangement of the ore, which is colored in gray-black, around the blue area, which is the shape of the limestone or marble on the 1,500 foot level. The ore is associated on the contact with the limestone, and it dips to the northeast, in other words, in this direction. On the 1,500 level, the ore is here. On the 1,600, it's at this position. On the 1,700 level, it's in this position. We also have ore both below and above the marble. This ore out here is on the top of the marble, as I will show you in the next sequence. This is a cross-section, or a slice. Across the ore is approximately this position. This shows a dip or plunge of the limestone and associated ore at the contact. The red is granodiorite and monzonite, which is responsible for the formation of the ore in a chemical contact with the limestone. So you can see there's ore above the limestone and there's ore below the limestone. Above the marble and pactate or skarn ore, as it's called, there's an upper layer, which is in darker green, of volcanic rock, which is thought to be an andesite. This was more or less laid down about the same age as the marble. There is an upper layer, a thinner layer of volcanics above what we call the lower andesite, which was laid down after all the ore was formed and after the marble was formed. And above this we have a younger Eocene limestone, which is more or less flat lined. This sequence happened approximately 66 billion years ago. They have it taken an age on the Brown diary, a radioactive age, so it's about 66 million years old. So the limestone was there before that, and probably the lower andesite, and this upper andesite and metal came later. We have approximately in the mine 440,000 tons of ore. Now this includes broken ore. In this sketch we see here, this is an idealized section of a stope that has been partially mined out. This area has been mined out. This area is ore in place. This below here is the broken ore. And this theoretically, this ore, well not theoretically, this ore is dropped down. This is a 1,300 foot, 1,300 foot level. This is a 1,500 foot level. When you pick the ore up on the lower level, it's dumped in cars either by a muck machine or a chute and trammed to the newest haulage up to the main haulage level.
The in-house assay lab keeps us up to the minute on quality control. Percentage of metal recovery in the mill, plus results in milling and mine production sampling to check for grade. The man you see is feeding a sample into the small crusher, the first step of the lab process. We complete about 30 assays per day to keep us abreast of current production. Tell me when you can start, Boone, and wait.
Here we go.
There are 2 of these Manchi electric locomotives in use, plus 1 air loco for moving ore cars from underground to the crusher bin. The locomotive engine is capable of pulling 6 to 7 loaded ore cars. Cuts down on labor and expedites the turnaround time of equipment back to the work area. This makes a heavier capital investment for more ore cars necessary. Now it's time to see where the ore originates. We are entering adit number 1. It is one of the 4 in use today. The travel distance to the first